Hello everyone, welcome to this video. In this video we are going to look at another subgroup test which is used in order to which is used mainly by beginners because it is a basic set as compared to one-step subgroup test. So remember, in one-step subgroup test what we were doing, we were taking two elements A and B from H, and for those two elements these could be arbitrary elements. That means the result should be true for all the elements which are member of the subset H. Then for these two we are proving that AB inverse is also present in H. So this was the one step subgroup test. Now in this two-step subgroup test, what we are saying for any two elements A and B belonging to H, AB should also be there in H. That means the closure property should be there, and A inverse should also be there in H. So if these two properties hold, so therefore we would say H is a subgroup of the given group G. So here you see, here we have only one step, here we have two steps, so that is why these names are given. So let me read you the statement here. If G is given to be a group and H is given to be any non-empty subset of the given group G, right? This is already given to be non-empty. So they are saying, if we assume that AB is present in H whenever A and B are present in H, that means the given set H is closed under the this operation of the group operation, and if A is present in H, then A inverse is also present in H. If that is so, that means H is closed under inverses. If both of these conditions happen together, then we can, by this test we can call that H is a subgroup of the given group G, right? So here this is the test. So now let's try and prove this step. The proof is very simple. So let's see how we can proceed here. So if we first of all assume that this condition holds, and we will prove that H is a subgroup of G, right? So let's see here. We assume that AB is in H and A inverse is also in H whenever both A and B are present in H, right? So these are the assumptions that is made by us, and we wanted to prove that H is a subgroup of the group G. So what we are doing here is, according to one-step subgroup test, we know that if H is a subgroup of G, so for H to be a subgroup of G, this AB inverse should be there in H, right? So this should be there in H. So we'll make use of this one-step subgroup test by making use of these assumptions here. So you see, if we suppose that A and B are present in our subgroup, in our subset H, because until now we do not know whether H is a subset or no. That is what we are proving here. So if we take A and B from the subset H, right, because H is closed under inverses, because this is what we have assumed initially, right? And moreover we have assumed that it is closed under the given operation, so that means it has the closure property. So because H is closed under inverses, so that means B inverse would be there, and because because we have the closure property here, it is closed by the given operation, so A is already present in H, B inverse is also in H, so that means their multiplication AB inverse would also be there in H, right? So AB inverse also belongs to H because both A belongs to H and B inverse belongs to H, and according to this closure property their product should also be there in H. If now AB inverse belongs to H, so according to one-step subgroup test we have H as a subgroup of G. So that means H is a subgroup of G, and this is what we wanted to prove here in this for this particular test. So I hope you understood this test well. Well, that is it for this video. Thank you for watching.